So now let's look at some operations that we can do with random variables. So basically, since random variables are mapped to the real numbers, we can do arithmetic with them. So let's say if x1 and x2 are random variables, let me abbreviate this, on the same sample space, S, then we can define new random variables. So a x1 plus b for any a, b real numbers is a random variable, again, on this same sample space S, which is defined by a x1 plus b. This random variable applied to an element S is equal to a x1 of S plus b. Similarly, x1 plus x2, we can take the sum of two random variables, or indeed more than two random variables, is a random variable on S defined by x1 plus x2 applied to some element S is just x1 of S plus x2 of S. And again, x1 times x2 does also exactly what you might suspect. So to give a quick example, if S is our sample space for 2 dice rolls, and x1 is the outcome of the first die, and x2 is the outcome of the second die, then x1 plus x2 is the random variable that measures the sum of the 2 dice rolls. So we will see a lot more examples of this next time when we talk about expectation and variance. But I want to point out a couple quick things to be familiar with and possibly little pitfalls. So here's the kind of thing that I have the potential to get confused by. So note, if instead we take S to be the sample space for 1 die roll, and we let x1 and x2 be the result of a die roll, which we consider as random variables on S, then x1 plus x2 is different from what we got up here. It is not the sum of 2 die rolls. It is twice the sum of a single die roll. And essentially what's happening is that you can think of this as sort of we chose the wrong sample space. Because our sample space is only the numbers 1 through 6, then x1 plus x2 is a random variable on this same sample space. So for example, on s equals 1, it spits out 1 plus 1. S equals 6, it spits out 6 plus 6. You won't get mixed terms because you only have sort of 1 die going on in the sample space. But I want to point out as well that we will often talk about random variables and leave the sample space implicit. So we're sort of being implicit that we're using the right sample space for the operations that we're talking about. But if you want to think explicitly about the sample space, you do need to be careful about what it is, because different sample spaces will give you different random variables. And again, hopefully this is not too unbearably abstract for now, but it will all be very much worthwhile when we talk about expectation starting next time.